I've got a clothing situation or costume situation. So which do you like better? So I was thinking about going as a pirate. So I could go as a pirate with an earring. Oh, there's my eye patch here. Or I could go as a skeleton. Which do you prefer? Do you like the skeleton or the pirate? See, the thing is every time I go as a pirate, kids steal this stuff, and I don't. I have to get it again. But so vote skeleton or pirate. Skeleton or pirate? What do you think? We have be there be treasure. Ah, you're right. Yar, matey. Spooky, scary. Yeah, it's not too bad though. You know what I mean? It's like it's pretty decorated. You know, it's like it's not so. It's kind of like the Day of the Dead kind of thing. Go with the skeleton. Right. I'm using it to hold my hair in place today. So good to see you guys. All right, skeleton. Some more scary. So I got to put my headphones on so I can hear you guys, or at least not so much background noise. All right. Oh, this earring is. Oh, that hurts. Ooh. I'm not used to wearing earrings. So, good morning, ladies and gentlemen, and happy Halloween to you. All right. So, we are doing, let's see, this presentation here. Let me get it for you. Give you a link here. You know, I try not to scare the little kids, right? You know, so I didn't know. But, you know, they see a lot. They see a lot already today. You guys probably saw a lot of scary stuff when you were growing up. Yep. You guys are big now. Now you got the Five Nights of Freddy, right? Okay, so here we go with this assignment. So we were talking about periodic ionic bonding, right? Ionic bonding. So ionic bonding. So this is what we talked about yesterday, and we started working on this stuff. So we're going to go into day 2 here and ask some questions here. Where are you? Day 2. Here we go. All right. Would you rather be, okay, so this is a response. Would you rather be always late and if or always unprepared? Let's see what I'm going to put this in a poll question as well. So A, always late or B, always unprepared. Always unprepared. So A or B. Which do you choose if you didn't get into the near pot or the pair deck? Which would you choose here? Always late or always unprepared? Let me see what these guys are saying here. So some are halfway, some are the. It looks like always unprepared. There's only one person that wants to do always late. Let me see who's in the pair deck here. So, hey Bradley, you know you probably needed the sleep, right, Brad? Probably needed the sleep. You know, so all right, so let's do the polling here. See what we got. We got. Thanks for getting in there, Gabby, Grace. So we got always unprepared. People would rather be unprepared than late. Okay. All right. Okay. So thanks for getting in there, ladies and gentlemen. So if you can get into the Nearpod, the pair deck. I don't know. I'm really saying some things here. Here is the pair deck. Here is the pair deck link. If you did that. Okay. I can determine the ionic charge of an ion. I can describe how valence electrons and atomic radius relate to differences in charge. Okay. We're probably not going to do that second part. All right. So just a reminder, form ionic bonding form when a metal and nonmetal bond together. They fill their octet in their valence shell. Remember, an octet is 8 electrons or 2 electrons. So if we remove a shell and we get down to one shell that has the first shell, so we have 2 shells, that's full, right? Or we get to 8 electrons where the valence shell is full. Both atoms become stable. Stability occurs when atoms gain or lose an electron when both atoms become an ion that causes an attraction. All right, so that's what we had from yesterday. So let's do this question real quick here. Let me get this question here, and I'll put this as in the question, in the poll question. So let me do a poll here. Start a poll. All right, together. Okay, and this is A, B, C, D. Okay, let's do this. Start a poll. Okay, so in the presentation, a strong attraction between 2 or more atoms, which holds the atom together. All right, so what do you think? What do you think? Is it chemical bond, hydrogen bond, ionic bond, or covalent bond? So this is something that we've been talking about just briefly. All right, so we talked about it a little bit. All right, so if you're in the pair deck, you don't have to vote. You're voting in the pair deck, and I have, let me see how many people show responses. So I got some people that say chemical bond. Oops, one person did chemical bond, moved it over to hydrogen bond. So we got some people put chemical bond as well. So I just wanted to show you what is going there. So this is, we published a poll, and we got one person that got this right on there. It is a chemical bond. It's a chemical bond. The strong attraction between 2 or more atoms, which holds atoms together. It's the general thing. It's a bond between 2 elements, right? So this is a chemical bond, right? Now, this one you'll get, okay? So this one you'll get. Let me go over here and I'll take this one out. All right, a strong attraction between 2 oppositely charged ions. You start a poll here. Okay, what is this one? Start this poll. Let's go over here. Oppositely charged ions. Okay, so what do you think in this particular one? Okay, thanks, Bradley. Thanks, Chloe, Dalton, John, Loader. Okay. Excuse me, I got to get a drink of water here. All right. All right, so we got some people are saying covalent bonds, some people are saying ionic bonds. So the key idea here is ions, right? Ions. And look at that, everybody's got it on the ion there. So publish the poll. So yeah, it's an ion. Okay, so ions, ionics, right? So that's what we've got here. All right. So ionic bond. Okay, so those are the 2 questions that I was interested in. Okay, so let's talk about ions and stability. So the charge on an atom, ionic charge, is the same number of the valence electrons, which is indicated in the group or column. All right. So calcium loses 2 electrons. This is a weird thing. It loses 2 electrons, and it has a +2 charge. Okay, if it loses 2 electrons, remember we can't change the protons. We can't gain protons to make them positive, because if we gain protons, we change the element. But if we lose electrons, which are negative charge, we can be positively charged. Ionic charge is the same number of the valence electrons, which is indicated by the group or column. Okay, so we've got the group or column um, showing the valence electrons there. All right, so the number of valence electrons is, as I said, the same as the group until you get to group 15. This group starts the anions or negative ions. Okay, so here we've got -3, -2, -1. Okay. Now, as I said before, the valence electrons in group 17 are 7, but what we're trying to do is we're trying to get an octet. Octet. Should write this with my other pen here. That would probably be better. So an octet is trying to get a full shell, right? Trying to get a full shell, and so an octet does that. So let's talk about that. Remember, so an octet is 8 or 2. So 2 is for the first shell. But octet means 8, right? Octet means 8. So in this particular case, chlorine has group 17 halogens have 7 electrons, but they can gain one more electron and become a -1. Okay, so they become an octet by gaining an electron. So group 16 has 6 valence electrons, but if they gain 2 electrons, they'll become an 8. Group 15 has 5 electrons, but if they gain 3 electrons, they become 8 again. So, and again, here, +1, this is the part that's, if they lose 1 electron, right, then they have a full shell. So here, they lose 1 electron. This one right here, when we get to the third shell, we lose 1, and the shell below it is as an 8 or 2. So these two right here lose 1, and then the shell below has 2. So that's full. So it's easier for metals to lose and then non-metals to gain. So that's the part that hopefully that makes sense to you. Negative ions, it's kind of hard to get your head around a little bit. Until you get to group 15, the group starts the anions or negative ions. Why? It is now easier to gain electrons than to take them away. So remember, stability of an element determines if an element wants to take or give an electron to obtain a full octet. If an ion is anion, negative, or a cation, positive, if the atom will take an electron or give an electron. So ionic bonding is therefore based on the number of valence electrons and the size of the atom. So we're not going to talk about the size of the atom in the ionic bonding theory. That's what Mr. Barnes was doing. I'm not adding that to this. Okay, so let's take a look at this one, group 13. So let's write this in together. Group 13 has 3 valence electrons. So it gives up or takes electrons to make the octet. Okay, so in this particular case, it gives up to make 8 below. So this one, because it's +3, it's going to give up to make a full octet with another atom. So here it's going to give these, because it's +3, it's giving 3 electrons away. Let me get track of who is in the pair deck so I can give them their points today. Okay, so let me take a look. Okay, so who is responding to this? I'll put this on my chart. Thanks so much for getting involved, ladies and gentlemen. It really makes a difference here. Hey, thanks, Maria. And we got Maria. All right. And you did that yesterday too. Thanks, Maria. Appreciate it. Chloe, thanks, Chloe. You did too. You were involved every day this week and last week. Rachel, thanks, Rachel. And John, second page. There we go. And let's see. Danny, thanks, Danny. And Loader. Loader. And DeAndre. Thanks, DeAndre. You guys are really there when I need you, helping out in the classroom. Okay. Kendrick. I missed you, Kendrick. Anybody else? Okay. All right. Okay, so charge, number of valence electrons. Okay, so let's write in this one. So let's do this one together. No, I'm just doing it by myself. Okay, so let me make this a writing one. I did not make it a writing one. New prompts. Draw, draw, draw. Drawing, okay. There we go. Okay, so let's draw this one together. Okay, so on the metals, okay, remember the metals are on the left. Are on the left side, and the middle and the non-metals are on the right. Okay, so the metals, again, this is what I was said for the lose electrons, become more positive, right? And those are called your cations because I have a cat that has paws, right? A little pause here, positive, right? So losing electrons. So these are the things you have to write down. Gaining electrons, it doesn't, again, you have to think about it. Gaining electrons becomes more negative, and those are your anions. I think of it as an onion. Okay, and if I'm going to eat an onion raw, it's going to be negative to me, right? But again, like I said, if you add it in salsa, I'm fine, right? So +1, group 1, +2, group 2, +3, group 13, positive or negative 14. It depends on if it's a metal or not. If it's a metal, it's a positive. If it's carbon and silicon, it's minus. -3 for, so if you see these right here, the reason, if I think about the valence electrons here, this is 5. 5 wants to be 8, wants to be 8, wants to be 8, and these don't bond at all. It's already 8. All right. Thanks, Chloe. Thanks, Danny. Thanks, Kendrick. Thanks, Maria. Thanks, John. Thanks, Loader, DeAndre, and Rachel. Had to cough, turn the microphone off a minute. Okay. So let's look at this one. Valence electrons, right? So lithium is in group 1. So lithium has +1 electrons. Fluorine has -1. Wants to be a negative to fill that in. Electron transfer, so the lithium transfers the electron to the fluorine. Ions form, so we got Li plus, which is the cation. It lost an electron. And F minus, anion, it gained an electron. More negative. Okay, and you can see what happens here. So when I lose an electron, okay, now I have 2 electrons here. That's a full shell. That's stable, right? So, and then when I gain an electron for fluorine, I become stable. I have 8 electrons, and I've got that, what they call that octet, right? So now this plus and this minus charge hold this together. That's why the 2 ions are held together through this, what they call electrostatic force. And it's a pretty strong force. Pretty strong force. Give you a second or so to get that in there. Let me do this a second, and then I'm going to close this out, and then I'll put this back up. As soon as I get my dashboard open. A lot of writing today. Thanks, Loader. Thanks, Kendrick. Thanks, Chloe, Danny, John, Maria. I lost Rachel. Rachel's still working on DeAndre. Still working on it. Okay. Give you guys a little more time to get that in there. Okay. Sorry, Brad. I just saw your other message there. We all misclick at times. Okay. All right, so W11 assignment 1, I'm going to pull people out to work on an alternate assignment to W11 assignment 1. It's not the same one. Now, what I want you guys to do is to, if you haven't done week 11 assignment 1, okay, some new things I put in there. There's me, the pirate outfit here. Hey, Kevin, how are you?
Say hi.
Your microphone went on. I muted you for a second. So if you go to the modules, okay, you will find that I have, let's go to modules. Okay, week 11. All right, so, all right, where'd you go? Did I put you at, oh, okay, it's at the bottom here for some reason. Okay, so week 11, it should have been at the top. Okay, notes and graphic organizer. So I added a graphic organizer here. Now, the graphic organizer for week 11 assignment, this should be for assignment 1, electron transfer. But I also have, I just realized that I can use the CAMI assignment. So if you need to use the electron transfer notes, you can use this. It's a little bit bigger, but what's nice about this is that you can play it. Whether you can hear it or not, I don't think I made it so you can hear it, but it'll read to you. So if you need text to speech, it has the notes in there, the crystalline structure. So these are the 4 slides that you could use for week 11 assignment 1. So go ahead and work on that. If you want to work on assignment 2, you can also work with that. You can use the notes here for assignment 2. Assignment 2 goes over today's pages as well. So these are all the notes for the week. All right, so I'm going to take the time here and open up a breakout room and get people in there to do this week 11 assignment 1. So if you are invited, please come, and if you want to work on the week 11 assignment 1 on your own, that's okay. But at least tell me that you want to do that on your own, okay? So if you're invited, please show up. Let me know, all right? Sure, Kendrick, I can do that. Okay, I'm going to stop sharing here and turn the computer